Hello students, welcome to the first video of this new playlist. In this playlist, I will upload solution video of each of the question from one of the most recent past paper of Mechanics 2, which is the October 2024 M2 paper. So this is the first video of the playlist. So in this video, we will be solving the first question of this paper. So let's get started with the first question of the paper. Okay, so here the question says, at time t seconds, t greater than where t greater than or equal 0, a particle p is moving with velocity v meter per second, where the velocity vector v, it is given as 3 times t plus 2 whole squared I plus 5t times t plus 2 j. Okay, position vectors are given relative to the fixed origin O. At time t equals to 0, P is at the point with position vector negative 30I, negative 45J meter. Okay, so part A here is asking to find the position vector of P when t equals to 3. Okay, so the velocity vector of the particle is given. From that we have to find out the position vector of the particle p at time t equals to 3. Okay, so we know that if we differentiate the velocity vector, then we will get, if we integrate the velocity vector, then we will get the position vector, right? Differentiating the velocity vector will give the acceleration. Okay, so if we integrate the velocity vector, we will get the displacement vector or position vector. Okay, so let's integrate the velocity vector. So for part A, we want the position vector s. Okay, so this is integration of the velocity vector with respect to t. Okay, so let's integrate. So the velocity vector would be integration, so the position vector would be integration of the velocity vector. Okay, so let's expand the I and j components of the velocity vector. So you will get 3 times t squared, t plus 2 whole square, so t squared plus 4t plus 4 I plus the j component is basically 5t squared plus 10t j. Okay, we have to integrate this velocity vector. Okay, 5t squared plus 10t. Okay, now so we got the position vector. Okay, let's multiply out the bracket. So 3t squared plus 12t plus 12I plus 5t squared plus 10t j dt. Okay, so let's integrate. Now we can integrate after expanding the brackets. So if you integrate 3t squared, the integration of 3t squared, it's basically we add 1 with the power of the variable, so t squared 2 plus 1, so 2 plus 1, it will make it t cube, and we will use the new power to divide the coefficient, so it will be 3 over 3, it is 1. Okay, next the second term, same goes for the second term, it will become t squared, the power will get added by 1, then use the new power to divide the coefficient, so it will be 12 over 2, it is 6 plus 12t. Here the power of t was 0, so as we add 1 with the power, the t becomes visible. Okay, I plus 5t squared is there, so the power will get added by 1, so it will become t cube, so 5 over 3 t cube plus 5t squared plus 5t squared plus c. The vector c, it's basically the lost constant or the lost it's basically the lost vector in the differentiation method, in the differentiation process, because as we have differentiated as the displacement vector to get the velocity vector, this vector c, it has lost because it had only constants, and we know that constants has derivative 0. That's why it got lost in the differentiation method. So when you integrate the velocity vector, you have to add this lost constant vector. Okay, so let's find out this constant vector, that is c, by using the position vector, the given position vector. When t was 0, the given position vector is negative 30i plus 45j. So we will consider t equals to 0. When t equals to 0, the position vector, it will become 0i plus 0j, right? All the I and j component becomes 0, so s becomes equals to the constant vector c. So c is basically the given position vector, that is negative 30i, negative 45j, negative 30i, negative 45j. Therefore, the position vector of the particle p, it is t cube plus 6t squared plus 12t, and then the I component of c, vector c, it is basically negative 30, so put it there with I component, and then the j component is 5 over 3t cube plus 5t squared, negative the j component of vector c, it is 45. That's the j component, and the unit for position vector, it is basically meter. Okay, so now they are asking at the time t equals to 3. So when the time was 3, t equals to 3, when the time was 3 seconds, the position vector s, it is equals to t cube plus 6t square. So t cube is 3 cube, which is 27, plus 3 square is 9. 9 times 6, it is 54, plus 12 times 3, it is 36, negative 30. That much I, plus 5 over 3 t cube. So 5 over 3 t cube is basically 5 over 3 times 27, 5 over 3 times 27, and then plus 5 times 3 squared, it is 9. Okay, and then negative 45. That's the j component, that much meter. Now just calculate, do the sum and multiplication. So at first, I component, 27 plus 54, it is basically 81. 81 plus 36, it is 117. So 117 minus 30, it is basically 87. So at t equals to 3, we got the I component of the position vector, it is 87i, and the j component, it would be 27 over 3, it is 9. 9 times 5, it is 45. So 45 plus 45, it is 90. 90 minus 45, it is basically 45. So positive 45 j, that much meter. That's the position vector of the particle p at time t equals to 3 seconds. That's the answer for part A. Fine. Okay, next is part B. In part B, the question is asking to find the magnitude of the acceleration of p when t equals to 3. Okay, we need to find out the magnitude of the acceleration of the particle t at time t equals to 3 seconds. Okay, so the velocity vector is given there, so we will use this velocity vector to find out the acceleration vector. So basically, the acceleration vector of particle p can be found by differentiating the velocity vector, because acceleration is the rate of change of velocity, right? So let's differentiate the velocity vector to get the acceleration vector. For part B, the velocity vector, at first let's expand the velocity vector. We know the expansion of the velocity vector we did in part A. This is basically 3t squared plus 12t plus 12, 3t squared plus 12t plus 12 I, that's the I component, and the j component is 5t squared plus 10t, 5t squared plus 10t, 5t squared plus 10t. Okay, that's the j component, that much meter per second. Okay, now we will differentiate the velocity vector to get the acceleration vector. Okay, so the acceleration vector 3t squared. the power of the variable will get multiplied with the coefficient. So 3 times 2, that would make it 6, and then we will subtract 1 from the power. So t to the power 2 minus 1, it is just 1. Okay, same goes for the second term, it will become only 12. So 60 plus 12 I plus, same rule, 5 times 2, which is 10, t to the power 2 minus 1, it is just t plus 10. Okay, we have just differentiated the velocity vector to get the acceleration vector. Now t equals to 3. When t equals to 3, the acceleration vector, when t equals to 3, the acceleration vector of the particle p, it is 6 times 3, it is 18. So 18 plus 12, it is basically 30I plus 10 times 3, it is 30. So 30 plus 10, it is basically 40 J meter per second squared. Okay, we got the acceleration vector. Now the question is asking for the magnitude. So magnitude is just finding the modulus of the vector, right? So modulus of the acceleration vector, it is basically using the Pythagoras theorem, right? 30 squared plus 40 squared whole square root. So that much meter per second squared. So 30 squared is 900. So 900 plus 40 squared, which is 1600. So sum is 2500. So square root of 2500, it is basically exactly 50 meter per second square. That's the magnitude of the acceleration of the particle p at time t equals to 3 seconds. That's the answer for part B. Fine. Okay, next is part C. In part C, the question says at time capital T seconds, p is moving in the direction of the vector 2I plus j. Okay, so part C is asking here to find the value of this capital T. Okay, so the time capital T, it is basically the time when the particle p is moving in the direction of the vector 2I plus j. So the direction vector is given, and we know that it's basically a concept from mechanics 1. The direction is basically represented by the direction of motion of a moving body. It is represented by the velocity vector of the moving body, right? So velocity vector is given there. So we will consider this velocity vector with this given direction vector to approach the value for capital T. So the direction vector, it is given as 2I plus j. Okay, so for part C, the direction vector, it is given as 2I plus j. Let me write it down on the right side. 2I plus j, this is the direction vector. So at time t equals to capital T, the direction is 2I plus j. So direction is represented by the gradient. If I show you 2I plus j, so 2I plus j is, this is 2I plus j, right? So the gradient of this line, it's what? Rise over run. Rise is basically the j component. This is the rise, which is 1, and the run, which is 1, and run is here, it is 2, the I component. So rise over run for this vector, direction vector, it is half. Okay, same goes for the velocity vector. For the velocity vector, the rise is basically the j component, which is 5t squared plus 10t. Okay, or we can write it as 5t. Okay, it is capital T now. 5t into capital T plus 2. This is the rise over run. Run is given here. It is 3 times capital T plus 2 whole squared. Okay, so 3 times capital T plus 2 whole squared. So this is rise over run. 3 times capital T plus 2 whole squared. Okay, so this is rise over run. It is equals to the same gradient. Since the particle p will be moving along this vector, direction vector 2I plus j, so they will have the same direction, therefore same gradient. Okay, so what we can do now, t plus 2 cancels out. So you will get 5t over 3 into t plus 2. This is equals half. Okay, now cross multiply. So if you do cross multiplication, you will get 10t equals to 3t plus 6. Okay, now just make t, capital T, the subject. So 10t minus 3t, it is basically 7t equals to 6. So the value for capital T, it is basically 6 over 7. That's it. That's what we got, the value for the capital T, and this is what part C of question number 1 has asked to find out. Fine.